We've talked about various types of inequalities, and this one we want to talk about a special case, absolute value inequalities. So recall that absolute value is telling us the distance from zero on the number line. So let's look at a couple very specific cases. If I say the absolute value of x is less than 3, that means my x, whatever it is within 3 units of 0 on the number line. So I start at 0, I go a little to the left, I go a little to the right, and that's as far as I can go. So my graph here, I start at 0 and go both sides all the way up to 3, but not including it because I want to stay distance less than 3, and I shade that whole section. So if my absolute value is less than something, I'm going to stay within a small relative neighborhood. In this case, if I want to turn that into an interval, I just find where I start and end, and I have my parentheses there, -3 to 3. As an inequality, my x is going to be trapped in between the -3 and 3. What if we flip the inequality and say, well, let's let x be greater than, the absolute value of x be greater than 3. Well, now what I'm saying is I want that distance to be more than 3 units away. So I have to go all the way out to 3 and a little bit past it before I can start deciding what I want my x to be. So I start right at 3 and then go as far as I want to the right, or I go backwards and I start at -3 and go as far as I want to the left. So now I get two disparate parts of a graph. I get two separate sections for an answer because I want to go to the extreme distances. So my intervals, I'm going to have two separate ones, is -∞ to -3 union, or the 3 to infinity. If I have two separate pictures on my number line, if I have two separate intervals, I've got to have two separate inequalities as well. So on this one, my original question or problem was the absolute value of x is greater than 3. When I come down and I look at it without the absolute values, I do see x is greater than 3, but I want to point out the other one is the x is less than the -3, because I have to go further to the right, greater than the 3, or left of the -3. So that's kind of tricky. You're going to have to flip the symbol and go left of the negative value. Let's take a look at a couple bigger examples. So if I have the absolute value of x minus 1/4 is less than 1/2. So I first have to decide, okay, which one is this? Well, if it's less than, I'm going to get less. I'm only going to get one little section. So I know that whatever this value is here, its distance is no more than 1/2 from 0. So it could be as far over as -1/2 or as high up as +1/2. But this value in the middle, it's going to be in the middle of those two. Okay, and then from there you just solve the inequality as normal. The next one, absolute value is greater than or equal to 8, so greater, or I'm going to get two separate things. So I'm going to get either this stuff here is greater than 8, so I'm going from 8 forward to the right, or this stuff in here, 6 minus 4x, is left on the negative side. Right? So I'm going to the left. So this is where I have to flip that symbol when I negate the number. That's the hardest part for students to remember, that second one, the symbol gets flipped when you use the negative. Again, you just solve each of these. Remember, if you're dividing by a negative, that symbol flips. So my answers here, I ended up with x is less than or equal to a -1/2, or x is greater than or equal to 7/2. Greater, we're going to get the two separate things. Never ever combine them into one. It's going to be two sections on my number line, and it's going to be two separate intervals. All right, one last slide here. So x plus 6 greater than 10, greater, or that's when we're going to get the two things. So I have two statements. Once again, it's the stuff inside is greater than the number, just like it says, or that stuff inside there is less than, so I flip the symbol, the -10. So when you get the second one for this one, you flip the symbol and you make it the negative number, because you want to go far to the right on the positives, far to the left on the negatives. Work that out. I have two separate sections on my number line and two separate intervals. If it is an absolute value less than or equal to, that's where you get the stuff in between. You go just a little left, a little right. In this case, we can go as far down as -3. So that's how I start my string inequality, with the negative of whatever this is, and it's going to be less than or equal to for all of these. So -3 less than or equal to the 4 minus x, less than or equal to the 3. Solve that. Remember, dividing by a negative, I flip my signs. And we also remember that we like to give our inequalities in numerical order. So if 7 is greater than or equal to x is greater than or equal to 1, I'm going to rewrite that and start with 1. So 1 then would be less than or equal to x, would be less than or equal to 7. So either way, x is trapped in between the 1 and the 7, and I can see my final interval answer here. I don't think you'll find these too tricky. You just really have to practice so you can get those rules in the brain. Let me know if you have questions.